Okay, so this is number 58, page 825. Again, you're going to be doing 57, which is way easier. This is not that hard. Oh, let's see. So again, if I want to do the difference quotient, the first thing, the hardest thing is you got to find the f of x plus h. So in this case, f of x plus h, what do I do with the x plus h? Put it in the place of x here. Right? The square root of 2 times x plus h minus 2, which is the square root of 2x plus 2h minus 2. Okay, f of x equals the square root of 2x minus 2. So when I subtract f of x, well, I'm not sure I'm going to have enough room here. Let me start it over here. I think it probably works better if I start it here. F of x plus h minus f of x divided by h equals the square root of 2x plus 2h minus 2 minus the square root of 2x minus 2 divided by h. And again, we are taking the limit of all of that. Okay, well, how do we learn to deal with the limit when there's a binomial radical expression? We multiply by the conjugate, right? So that's what you have to do in a problem like this. So what is the conjugate of this going to be? Right, it's this same thing, but that becomes a plus, right? So let me do that. That is the square root of 2x plus 2h minus 2 plus the square root of 2x minus 2 divided by the square root of 2x plus 2h minus 2 plus the square root of 2x minus 2. Okay. Let me come down here like this. The limit as h approaches 0. All right, let's do the numerator. The first terms, right? If you take the square root of 2x plus 2h minus 2 times the square root of 2x plus 2h minus 2, you get 2x plus 2h minus 2. And then middle terms cancel. The square root of 2x minus 2 times the square root of 2x minus 2. 2x minus 2. Okay, in the denominator we have the h, and we have the square root of 2x plus 2h minus 2 plus the square root of 2x minus 2. Now at this time we're looking for a lot of things to cancel in the numerator. And if you notice, let me change colors here. The 2x cancels with the 2x because that's a minus 2x. This minus 2 cancels with this. It's minus a negative, so that's plus. And the only thing that's left is 2h. Right? In the numerator, that's all we've got left. So this is the limit as h approaches 0 of 2h divided by h times the square root of 2x plus 2h minus 2 plus the square root of 2x minus 2. And again, it's important that at this step, the h's cancel. Right? Cancel, that did not go. Cancel, cancel. That's how you know you're on track, because it's working. And now I'm going to take this and go around to here. The limit as h approaches 0 of 2 divided by the square root 2x plus 2h minus 2 plus the square root of 2x minus 2. That was a minus 2. So now what happens if you do direct substitution? Does it lead to a divide by 0? I mean, notice the reason that it led to a divide by 0 up here, right, is because that was a minus, right? Because if you put in a 0 here, now you got the square root of 2x minus 2 minus the square root of 2x minus 2, 0. But that's a plus now. So when I put in h equals 0, I've got the square root of 2x minus 2 plus the square root of 2x minus 2. So this is the limit as h approaches 0 of 2 over 2 times the square root. Actually, that's not even a limit anymore because we substituted for h equals 0. 2 times 2x minus 2. And of course, you could cancel the 2's. Well, there's a lot of 2's going on there, but you can cancel that 2 with that 2. So the answer is 1 over 2x minus